For today's video notes, you will need IC65. This is part 2 of standard 15. We are continuing to look at surface area, but this time the geometric solid we are focused on will be a pyramid. So just like last time, as a reminder, surface area is going to be the total area of all the faces or all the surfaces of a geometric solid. So for pyramids, we're going to take all of the triangular faces that meet at a point and then the base of the pyramid, and we'll add them all up. To do that quickly, we can use P times L over 2 plus capital B. Now, some of you are familiar with the cursive L from earlier in the school year when we were working on our special right triangles, those 30, 60, 90s, 45, 45, 90s. This L is going to be a little bit different than that, so we're going to use L in a different way for this standard. Okay, P is still what it has been for the last few standards. We're looking at perimeter. It continued to be of the base of the geometric solid like it was for prisms yesterday. L, that new cursive L, is called the slant height. And what it does is it describes the difference between the point of the pyramid, which is called the apex, and then the base edge of the pyramid. And we'll look at what that looks like in some figures down below. Capital B is the same as yesterday. That's going to be the area of the base of the pyramid. So we'll find that using our formulas from standard 14 for area of two-dimensional figures. And then capital H, like yesterday, is going to be the height of the solid itself, which will describe the distance between that apex, that point of the pyramid, and then the center of the base. That's where the height is located in pyramids. And then there's one other detail about pyramids that we need to know, not because it's part of the formula, but because sometimes we're given the information, and that's a lateral edge. The lateral edge is going to be the distance from the apex again, that point of the pyramid, but this time it goes to the vertex of the base. So we have 3 different things that start at the apex of a pyramid and travel to 3 different places. The slant height is from the apex to the base edge. The regular height is from the apex to the center of the base. And then the lateral edge is from the apex to the vertex or a corner of the base. Okay, let's take a look at identifying these key features in some pyramids. So for each of the pyramids below, we're going to shade the face that should be used as the base. I'm going to continue to use yellow for my shading. And then we will highlight and label a distance that represents the slant height. Okay, slant height, that's going to be that cursive L. I might also label the capital H height and maybe the lateral edge on a few of these just so that you can see how they're different. But what really matters for us when we're doing surface area is identifying the base correctly and identifying the slanted height correctly. Okay, so for this first pyramid, the apex is this point at the top and the base is the face that is across from that. If there's a shape in your pyramid that is not a triangle, that must be the base. So for this pyramid, the base is rectangular, it looks like. It's a little bit slanty, but remember that just to get it to look 3-dimensional to our brains. So this is going to be a rectangular, it might be a square, but we don't know that necessarily for sure, pyramid. And the slant height is actually already shown in this rectangular pyramid on one of the faces. It starts at the apex and it travels to the base edge. This down here is the base edge. But a little bit more specifically than that, it makes a right angle and it also divides that base edge in half. So that right there is our slant height. Moving on to the second shape, we can see our base again, this not triangular face. This time it has 1, 2, 3, 4, 5 sides. So this is going to be a pentagonal or pentagonal pyramid. Different people say that word different ways. Our slant height does not look like it's already drawn in. You might be tempted to draw it in straight to the front, but that's going to get a little bit confusing later on down the road. So I'm going to try to be consistent, and I'm always going to try to sketch it in kind of over to this right-hand side. That's going to be the slant height. Remember, it makes a right angle, and then we could mark these as being congruent to each other because it travels to the midpoint of that side. Okay. Number 3, we've got a face at the bottom here that's not a triangle, so that's going to be our base. We shade that in. And then we do have a slant height drawn in again, and it's over here along the edge, that right-hand side of the shape. That's our slanted height, making that right angle, dividing that side up in half. And then for this picture, I'm going to actually go ahead and name this right here. That is the actual capital H height. It starts at the apex and then comes down through the middle of that pyramid to the center of that base. So that's what the capital H height of the pyramid would look like. This base 1, 2, 3, 4, 5 has 6 sides, so this will be a hexagonal or hexagonal pyramid. All right. Last but not least, this pyramid has all triangular faces, but since the apex is here at the top, we're going to choose the triangle at the bottom to be our base. Go ahead and shade that in. We've got a slant height right here, splitting that side in half, and because that's a triangular bottom, we're going to call this a triangular pyramid. Okay, I showed you what the capital H height looks like in one of these pictures, so I'm going to go ahead and show you what a lateral edge looks like in one of them as well. I'll do that on this last one. These solid connectors at the edges of the triangular faces that meet at the apex are the lateral edges. So they're the place where two of those triangular faces come together. So anytime you see one of those solid lines coming from the apex down to one of the corners of the base, that's going to be a lateral edge. Again, you don't need that to find the surface area, but sometimes they give you the lateral edge, and so you'll have to figure out a way to use it to help you find, usually the slant height, but sometimes also some features of the base of the shape. Okay. Now, in these pyramids, there are all sorts of triangles that hide that we might need to use to help us track down features that are missing that we need for solving problems. We can kind of see the triangles start to be created in this number 3 pyramid. If I were to go ahead and connect that capital H height to that slant height there, we all of a sudden have a little right triangle that's hovering inside this pyramid. We can also kind of see in this last triangle, there are right triangles on the face of these shapes as well, okay? And so both of those different right triangles can help us to track down features that we might need to solve problems. That's what this little investigate box at the bottom is for. So, since our formula involves L, the slant height, sometimes we need to find that L using a right triangle that exists in the pyramid. And along with that right triangle, typically it's going to be Pythagorean theorem that helps us out. As a reminder, that's our c squared equals a squared plus b squared equation. Okay? And the reason why it's usually Pythagorean theorem is because we don't often have angle measures. And so that means our special right triangles and our sine, cosine, tangent doesn't usually work out super well. And so if we look at this number 3 right triangle that we created, we might have a situation where that capital H height through the middle of the pyramid is connected to that slant height out on the face of the pyramid. And then this feature along the bottom can kind of be represented by different things. If our base is one of these regular polygons, that's actually the apothem, okay? If our base is a square, we can technically call it the apothem, but we can also call it a half of a base edge. So that bottom piece sometimes is a little bit tricky to track down, but we'll practice finding that. And so if we look at that triangle, that slant height, that L, would be our C value across from the right angle. And then our capital H height and our apothem would be the A and the B part of that formula. The other option is the right triangle I showed you here in number 4. So if we look at this right triangle, the slant height is actually over here on the left side of that triangle connected to the right angle. Across from the right angle is one of those lateral edges. Okay, we don't really have an abbreviation for lateral edge, so we just have to fill that in. And then the bottom of that triangle is half of this base edge. So half of that distance along that base edge. And so Pythagorean theorem in that case, the C would be that lateral edge. Squeeze that in there. And then the slant height and that half base edge would act as the A and the B part of that formula. So you have to be really careful at visualizing whether you're using this triangle that's kind of hovering inside the pyramid or this triangle that's laying on the face of the pyramid when you're trying to solve for things that are missing. All right, go ahead and flip the page over and I'll meet you back here for some examples. All right, we've got 4 examples to work through here today. This first pyramid, they're telling us, is a square pyramid. That first word gives us a clue about what to use as the base of our shape. So we're going to go ahead and shade in that base. I am noticing that we also have right here a slant height available. So that's going to be our cursive L. And since we're dealing with a pyramid, we know our surface area formula is going to look like PL over 2 plus capital B. So our goal, just like with prisms, is to find the perimeter of that base. So we're thinking about traveling all the way around that square. Well, square is going to have 4 sides that are all identical. So I'm just going to do 4 times 6, but you could also do 6 plus 6 plus 6 plus 6. That would be fine. And our perimeter then is going to turn out to be 24. So that's going to kick off our surface area calculation. The slanted height was given to us this time as 10, so we can plug that in, which means all we need to track down is the area of the base. So thinking about a square, base area would be lowercase b times h. Each of these sides can act as the lowercase b and the lowercase h, so we're going to do 6 times 6, and the base area turns out to be 36. All that's left is to calculate. So we're going to do 24 times 10 divided by 2. That will give us 120. And then add in the 36 from the area of the base. So our final answer for surface area for this first pyramid would be 156 square centimeters. All right, onward to number 2. We're running into another pyramid, but this time the base is a pentagon. That does not change the formula for surface area, so I'm going to go ahead and get that written down. PL over 2 plus capital B. All that happens is our perimeter involves a few more sides. So we've got 5 sides this time that are all equal to 9 for a total perimeter of 45. And then we do still have a slant height available to us right here, down the middle of that face from the apex to the middle of the base edge. So that 15 will get plugged in for the slant height. And then we need a capital B. So to find that capital B, we're looking at the area of the base. The area of a pentagon can be found by doing AP over 2. Well, the good news is we already have the perimeter. The The bad news is I don't see any kind of apothem information on the base of that shape. So I'm going to need to pop out to the side here and work on a pentagon problem, which means the apothem is that vertical segment. We know that this whole side is 9 from the picture, and we know that it gets split in half. So we're going to have 4.5 and 4.5. We need that angle at the top to help us find the missing apothem value. So if we've got a pentagon with 5 sides, we can find that angle by dividing by 10. So that's going to give us 36 degrees, which tells me we're going to need to take a sine, cosine, tangent approach here. So if I'm at that 36 degree angle, 4.5 would be the opposite, and the apothem would be the adjacent. So tangent of 36 will equal the opposite over the adjacent. Multiply both sides by the denominator to get that fraction taken care of, and then come back in and divide both sides by tangent of 36 to track down that apothem value. Now this is going to create a decimal for the apothem value. So remember, we're going to be careful to keep that nice and exact on our calculator. You can write down on your page what it's close to, but we're going to try not to round that problem at all, or that piece of information at all, until we're completely to the end of this problem. First things first, let's take it back to our AP over 2 formula. So that number from my calculator with all those decimal values is going to get multiplied by our perimeter of 45 and divided by 2. So times 45 and divided by 2 now gives me my base area of 139.35, still with a bunch of decimal places. Bring that up and plug it into the surface area formula. 139.35 with all those decimal places needs to get added on. So I'm just going to add to that the PL over 2. I almost forgot that part of the formula. So we're going to do 45 times 15 divided by 2 for the PL over 2 part. Click enter, and that should give us our surface area that we can now officially round to those 2 decimal places they ask us about. Since that third digit is an 8, we're going to round this up. So 476.86 square centimeters for the surface area of this pyramid. All right, on we go to the last 2 examples. Moving ahead to number 3, they give us a clue that we're dealing with a hexagon as the base. It is possible for pyramids to not be drawn with the point at the top. All of these are drawn in that way, but they might be kind of rotated or upside down or flipped on their sides. So just realize it's not always the bottom, but it will always be named as part of the pyramid's name. I'm noticing something different about this one. There is no slant height in the picture, which is why this little triangle has been set up next door for us. We do have that capital H height going from the apex to the center of the base. So that would be this side of this little right triangle. This slant height is what we're going to look for. And the bottom of that is actually inside that base, and it's the apothem. So I think what makes the most sense on this problem, once we get our formula written down, is to actually start backwards and focus on that base area first. Because for base area, we need to find the apothem, and then once we have that, we'll be able to use it to help us also find that slant height. All right, so since we're in base area mode, for a hexagon, that will be AP over 2. If we go ahead and we draw our little triangle set up here, we're missing the apothem. But we do know that an entire side is equal to 10. That's going to give us a 5 and a 5 that we can use. And then our angle at the top will come from taking 360 and dividing by 12, since there are 6 sides. And it will give us 30 degrees, which is great news, because that means that this is the shortest leg of the triangle, and this is that L root 3 side. So if 5 is equal to L, we know right away that our apothem value is equal to 5 root 3. If we go ahead and we finish this out and we think about perimeter, because that's the next piece that we need, perimeter is going to end up taking 6 of those sides that are all equal to 10 and multiplying them together. So we'll have our apothem of 5 root 3 times our perimeter of 60 divided by 2. I'm going to go ahead and keep that base area exact because then we won't have to worry about it getting rounded too soon. And I'm also going to remember that that apothem value that I just found is going to help me as I work to find my slant height. So I'm going to add it on to that right triangle picture that I have set up ready to go. Okay, let's go ahead and knock out the slant height, and then we should be able to plug everything in and find our surface area. So this is going to be a c squared a squared b squared setup, where our slant height is the c, the hypotenuse across from the 90-degree angle, and then our a and our b values will be 15 and 5 root 3. Slant height squared will equal 225 plus, remember to be careful when you're squaring these, you should end up with 75 when that's squared. 5 squared is 25, root 3 squared is 3, 25 times 3 is 75, or carefully use your calculator. So then L squared is going to be equal to 300, and we're going to square root to figure out what L is equal to. Now we have been asked to give both an exact and a rounded answer for this. So I'm going to simplify this radical so that I can get to an exact answer. If the only request was rounded, we could just leave it as root 300 or find a decimal value for it. But because we need an exact answer, I'm going to think about how this is really a 100 times 3. The square root of 100 is 10, and then root 3 would be left behind. You can use factor trees, factor tables, or perfect squares. For that, I used perfect squares to simplify just there. All right, let's plug it all in and get our final answer. So our surface area will be our perimeter of the base. That was 60, all the way around the base of that pyramid. Slant height comes next, which is 10 root 3 divided by 2 plus our base area, 150 root 3. 60 times 10 root 3 will be 600 root 3, divided by 2 will give us 300 root 3. And because both parts of this addition problem have root 3's attached, we can go ahead and combine, and our exact surface area would be 450 root 3 centimeters squared. That would be our exact surface area. To get a rounded surface area, we'll go ahead and type that in and have the calculator give us a decimal value. Take a look at that third decimal place. We're not going to round up in this case, so 779.42 would be our rounded surface area. All right, one more example to go. If we look at this last problem, we have an equilateral triangular pyramid. So triangular tells me that this triangle at the bottom is going to be my base. We'll go ahead and get our surface area formula set up here so that we know what our goal is. PL over 2 plus capital B. And then I need to remember back from a long, long time ago what equilateral tells me. Hopefully you remember that means that all of the sides are congruent. So even though 14 only shows up once in this picture, and even though it doesn't seem like all of these sides are congruent, when I'm thinking about the edges of this base, they're all going to be the same. 14, 14, 14 all around. So my perimeter will just be 3 times 14, or 14 plus 14 plus 14. 42. Okay. I'm on the hunt now for L, my slant height, and I'm feeling like it is again missing. But this time, I'm noticing I have a lateral edge over here hiding. So the right triangle that I'm going to use is this one that's flat on the side of the shape instead of the last time where it's kind of hovering in the middle of that solid. That 14 gets split in half. And so again, I have an opportunity to use my c squared a squared b squared equation, but that lateral edge is the hypotenuse, and then the slant height and the half base edge are the a and the b values. 18 squared is 324, 7 squared is 49. So we do a quick subtraction here. 324 minus 49 gives us 275. And then for this problem, take a sneak peek at the instructions. We are going to round. So I'm going to be a little bit lazy on this one and just leave this as the square root of 275. Since I don't need an exact answer, I don't technically need to simplify that. You certainly can if you would like. It turns out to be a 5 root 11 if you are curious. But you can get away with using that square root of 275 in your calculation and everything will turn out just fine. All right, so we've got our perimeter tracked down, we've got our slant height tracked down, so we could fill in the first part of this formula, 42, times that 5 root 11, or the square root of 275, divided by 2. We need to work on base area. I'm going to move down a little bit to do that because this is a triangle. They told me it was an equilateral triangle, which means I've got 14, 14, 14, but that also means I don't actually have a lowercase b and a lowercase h available to find area. And the reason for that is that there is no right angle in this picture. So rather than try to do all this work inside the pyramid where things would get messy, I'm just going to take a look at the base outside of the pyramid so that I can get that lowercase h drawn in. That would be like lying flat on the base. It'd be super hard to show inside that picture. And that's going to give me a 7 and a 7. And if you remember one more detail, you can find it rather quickly. Equilateral triangles have 60-degree angles. So these are actually little 30, 60, 90 triangles, where the shortest leg is 7, the longest leg is 14, so that works out perfectly as 2L. And that tells me that my height is actually going to be 7 root 3. You could also find that doing Pythagorean theorem, but a little bit faster if you notice that that's a special right triangle. So our whole base is 14. Our whole height for that base is 7 root 3. We're going to go ahead and multiply those together and keep it exact for right now, which should give us a 49 root 3. To bring back up to our surface area formula and plug in for capital B. Now this right here is why the instructions tell us to round to 2 decimal places. These are not going to be like terms since one of them has a root 11 and one of them has a root 3. So very carefully, we're going to take care of 42 times 5 root 11. If you want to keep going and divide by 2, make sure you close up that parenthesis before you divide by 2. So that's the first portion, PL over 2, plus 49 root 3 for the base area. So that's going to give us a rounded surface area of 433.12 when we round it up according to our rounding rules. Sneak peek at the units, and we are in square centimeters. Oops, sorry. All right, that is it for the surface area of pyramids. Thanks for watching. We will see you back in class.